Hello. Yes, we welcome you back to PSSB, Physical Sciences. Silver Bullet with me, Richard here. Yes, today we are starting with this question. It says that the diagram below shows the roller coaster having a car of mass 1,500 kilograms. And they say electric motor pulls the car to W. This is the car, and the electric motor pulls it to W at the top here. And then the question says, state what happens to the gravitational potential energy of the car as it moves in the following sections. They say write increase or decrease. The first one is VW. So what happens to the gravitational potential energy as the car moves from V to W? The answer is increase. Okay. Then we come here, W to X. W to X, decrease. Then we come to XY. XY, increase. Then we come to YZ. YZ, decrease. Okay, you are going to come to understand that because potential energy is represented by mgh, where m is not changing, is constant, and g is constant. So the only variable we have is h. So when h increases, as from V to W, the gravitational potential energy increases. And when h decreases, as from W to X, the gravitational potential energy decreases. So that's what we look for. We look for h. Increase in h implies increase in the gravitational potential energy. And the decrease in h implies decrease in the gravitational potential energy. Yeah, then this question comes. It says that state the phases on the roller coaster during which kinetic energy is increased. Okay, we need to know that kinetic energy is increased when potential energy transforms into kinetic energy. That's during the drop. So which phases are representing that? The phases are 1, W, X, and 2, Y, Z. Yeah, during these phases, potential energy is converted into kinetic energy. So the amount of kinetic energy is increased. Yeah, then comes this question. It says that calculate the gravitational potential energy at Y. Okay, so this is Y. And what is it? We'll have to remember that the gravitational potential energy is given by this expression, mgh. Okay, where EP is what we are looking for. The mass is 1,500 kilograms. G is constant, which is 9.8 meters per second squared. And H at Y is 10 meters. So with this information, what do? We substitute here and we say M is 1,500 times G, which is 9.8, times height, which is 10, giving us this, which is 147,000 joules. Yeah, so we come to this question. It says that what is the kinetic energy gained from Y to Z? Yeah, what is it? Okay, you have to remember this is Y, this is Z. And because mechanical energy is conserved, so the whole amount of potential energy at Y is the one which is converted into kinetic energy at Z. So the answer here is going to be the same. What is it? 147,000 joules. So it's the same. That's what we call conservation of mechanical energy. At both Y and Z, mechanical energy is the same. So here, the entire mechanical energy is existing as potential energy, which all of it is converted into kinetic energy as the borrows to Z. So at Z, all whatever was potential energy has now been converted into kinetic energy. Yeah, now this question comes. It says that calculate the amount of kinetic energy gained from W to X. This is W, this is X. So how do we calculate this? Yeah, to perform this calculation, we have to know that according to the principle of conservation of mechanical energy, when the object is moving from W to X, there is loss of gravitational potential energy. But you have to know that this loss is equal to gain in kinetic energy. Yeah, the loss is equal to gain in kinetic energy. But we can calculate the loss. The loss is EP equals to mg delta H. When you check for what we have in terms of data, yeah, EP is what we are looking for. Mass is known, okay, and delta H is the difference, which is 6 minus 4, giving you 2 meters. So when you substitute for those, what do we get? The mass is 1,500, the G is 9.8, and the change in height is 2. What do we get? Yeah, that is it. This is what we get, which is 29,500 400. So this is what we have as the loss in potential energy. But we must not forget that the loss in potential energy is equal to the gain in kinetic energy, which is wanted by the question. So the answer is the same. That's the answer to 9,400 joules. And with that, I would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet, with me, Richard, here. I would urge you to subscribe, to comment, to like, to share. It's we believe we are simply the best. See you next time. Bye bye.